So quite a few of the cameras from Ophir Spiricon have a large active area to them, or a large resolution. How do you know which resolution to pick? Well, on our source tab, we have what's called a frame format section. And this allows you to be able to set the different resolutions for the cameras. Normally in a default mode, when you first connect your camera, it's going to come in at the highest resolution, fastest frame rate possible at that resolution. How do you determine which is right for your application? Normally you're going to start with the highest resolution, fastest frame rate possible. But depending upon if you want faster frame rates or more resolution, it's a balancing act. You have to decide, do I want more resolution or do I want faster frame rates? So you have the option to be able to pick different resolutions from the camera. Sometimes, like in our case here today, our beam is relatively small. You don't need to digitize the entire active area of the camera. So you can then pick and decide, I want to digitize the whole area or I want to digitize a much smaller portion. So what I can do is I can change, instead of digitizing the full active area of the camera at the highest resolution, I can digitize a much smaller active area from the camera. Effectively, it looks like I've just zoomed in on that area of the detector. You have the option to run either 8 bits or 12 bits. Really, 8 bits is not used a lot much anymore. Most often you're going to use 12 bits because it gives you the most dynamic range and the best performance out of the camera. With as fast as the computers are today, you really don't have much of a performance hit going from 8 bits all the way to 12 bits. And you don't gain a lot by dropping down to 8 bits. But if you do, and you want to be able to run in 8-bit mode, it has the ability you could actually output an 8-bit data. By changing our resolution, it's going to affect how fast the camera can run. If I'm digitizing less, I can run the camera at a faster rate. If I want to run at the highest resolution, it's going to cost on the side of speed. So, since I've reduced the total active area that I'm digitizing, I now can increase my frame rate. As a default, this camera runs at 7.5 frames a second. But since I've reduced to a much smaller area, now I can increase my frame rate. Instead of 7.5, I can now run at 15 frames a second. It allows me to run a lot faster, see much more information in a shorter time period. One nice advantage of the beam gauge and some of the cameras is you can do what's called a custom region of interest. This little green arrow right here allows me to turn on that function. And I can set the custom ROI for this particular camera. Right now, I'm digitizing the whole detector. But if I wanted to look at a much smaller region, instead of just an 800 by 600 resolution, I can change that. By clicking here on the side, I can then change the area by reducing it to a much smaller area. So I'm going to shrink this down to cover just the area that I want to look at from this particular camera. And then I'm going to center it right over my beam. Makes it very easy. When I check this little box, it's going to set that resolution and it'll zoom in right on that detector. So now I'm viewing a much smaller area. And if I go ahead and I block my beam again and re-ultracal, beam gauge is only going to be looking at a much smaller portion of the detector, but I can do it at a lot faster frame rate. Notice I'm now running at 26 to 28 hertz. So if you've got a really small beam, you can either, one, use an aperture, or you can actually do our custom ROI and zoom in just on that portion of the detector and get a lot higher performance out of the camera.